Okay.
and then hit share.
Right. Thank you.
There we go.
You're very good.
Okay, you're good.
Okay, how do I get that green thing
I'm
off?
going to
There?
unmute though. So
I am unmuted.
no, in the Zoom.
Oh, I thought I did.
Oh, sorry. I'm looking at that one. I'm confusing myself. You're fine.
Can you hear me on Zoom?
Closer microphones. That's pretty cool. Do the cameras point themselves?
Can you tell if you can hear me Zoom? No clue.
Cool.
Yes, we hear you
I
on
don't know.
Zoom. Perfect.
Can anyone hear me?
You're perfect. We hear
Besides
you.
people in the room?
We
You
hear
need
you.
to
We
answer
hear
him.
you.
Can you come on? Somebody come on mic and answer him because we can't see the chat.
Tell me if you can hear me because we have no clue.
We can hear you. We hear you
Cool, right?
fine.
Everybody says they can hear you fine, and I can hear you fine too. But it's going to be like a quarter of a second later than your actual lips moving.
Oh man, all right. I could just talk like this and then you won't know. I'm gonna.
Says yes.
Okay.
Everybody loves the audio. On with the show.
Yay! We did we've been working over the years on this antenna control system for our client Radius Labs. I have a picture of it here. This is what one of these looks like, and it's a rack-mounted system. We've done several versions of this now. The original just tracked geosynchronous satellites. Now we're doing GEOs, LEOs, and MEOs with different kinds of hardware. The LEOs are fun because they're really fast.
So speaking of TLAs, low Earth orbit.
Low Earth orbit satellites, medium Earth orbit satellites, and geosynchronous satellites. Sure, or geostationary. There's a debate on that. So it's a rack mount unit, and the control panel is a touchscreen computer with a graphical user interface that's written in SWIFT, and it runs on an embedded Windows. And recently, we had two requirements that came up at the same time. One where we had to be able to run on Linux as well as Windows. And this was all written in the Win32 API, so that's a little problematic. And no, we won't use Wine. And the second one was that we had to support multiple screen sizes. And of course, this being written in the Win32 API meant that everything was very carefully sized and placed. So doing another screen size meant basically going around and just doing that all over again. I was inspired by one of my European colleagues who had done quite a bit of stuff for laundry control systems, Nick Nelson at Micros Automation, who had done this using GTK. GTK is the GIMP toolkit, and it's a graphical user interface library that's open source that's made up of a gazillion widgets. So if there's a widget you need for a graphical user interface, by God, they have it. So the reason that was nice is because it's cross-platform. It runs equally well on Windows, Linux, and Mac OS. The current iteration of GTK is GTK4, and it's all based on a really beautiful box model where everything just sizes itself just right. And it can kind of make you crazy because it's hard to get all the positioning right, but once you do, it works really beautifully. So there are three aspects to what, oops, hello, this way. Just three things, three kind of high-level topics. One is SWOOP, which is our object programming package. The second is the external library interface, and the third is GTK itself. Oops. I'm working in two dimensions here. The SWOOP is our object-oriented programming package, and we use that a lot in this application anyway, so there was nothing for me to learn for it. And it's just the traditional object-oriented programming, and it has encapsulation, information, hiding, inheritance. It turned out that the GTK object model maps itself very nicely onto SWOOP classes and subclasses with both data and methods. Some of the earlier attempts or other attempts I've seen at using GTK from a fourth application literally takes all of the function calls, and there are about 100,000 function calls, implements them all as external library calls and calls them directly from the fourth source, keeping track of all of the pointers and handles that you have to do. And it is unmanageable in anything but a very, very small application. So what I did was I wrapped it up such that I followed the GTK object model and just wrapped all those things up into class and then instantiate them into objects in my fourth program. So here on the SWOOP side, just a quick high-level view of it. Here's a simple example of a SWOOP class. We have a class called point. It has some private data, variable X and variable Y. It has some methods, set, which sets both X and Y, get, which retrieves them back to the stack, and show, which just dots them out for you. That's a nice little debug tool. I don't mean to be changing screens here. Then end class just says this is the end of the class. Now you have this nice little package. Here's an example of how you use it. There's a static instance of the class point whose name is origin. I can individually write into its data by referring to them by the name of the object and then the data within it. So I can write to X directly just by saying 5 origin X store, 6 origin Y store. This is all done with the magic of word lists, by the way, if you are familiar with the way word lists are defined in standard fourth. Very powerful. The second thing you could do is if you just want to do them both at once, you can use the method that I provided, which was sets. You can say 5, 6 origin set, and it's a little bit tidier and easy to read. And again, it's just fourth code. Yeah. You can retrieve the two values individually by saying origin X fetch, origin Y fetch, or you can just say origin get and just pick them all up at once. So that's how that works. We have an external library interface in fourth that lets you bring in basically C function calls. They don't have to be C, but they're mostly C function calls from external libraries. In Windows, those are DLLs. In Linux, whoa, hello, what did I just hit? Sorry, hang on. Went away. What? Did I close it? Stand by. Okay, here we go. In Windows, those are DLLs. In Linux, they're .so, shared object files, and in the Mac, they're .dylib files. So the typical way you use this is you say library, the name of the library name, and then you can define your importations with the word function colon, which has the name, which is the actual name of the function in the library, which now becomes a fourth word. And then you define the interface to it with something that looks just like a fourth stack picture. And it's the arguments that you pass to the C function in left to right order, just as you would in the declaration. And then the return value, if there is one, comes out on the other end of the stack. And then the other thing you have to do, so that's the way you get into the library, and the library might want to get back to you, callback, and you can define a callback, which is a fourth word that returns the address of the callback code that will call a fourth word whose execution token is XT, and it takes n arguments from the fourth stack, or returns, or actually passes for arguments in. For the GTK library interface, I needed to refine this a little bit. I wanted to extend library so that I did keep doing different versions depending on which platform I'm running, because I want to be able to take the same source file and load it wherever I want on Windows, Linux, or Mac OS. So I made a word called X library, which is just extended library that can take as many file names as you want. And when it runs it, it figures out where am I, which one do I want, and it opens that library. And then all of your subsequent function colon words are referring to that library. And if you have multiple libraries, then you just open another one into the function calls and keep going. And G callback is just a shortcut for callback because you don't have to do any stack cleanup for GTK. They're very nice. They just take care of that for you. So you don't have to tell it the number of arguments it's passing you. You just throw it away. So, okay, that's the end of the kind of the overview part. And then down in the weeds, I took all of GTK. This was sort of an after project. I thought, oh, what would it take to take all of the GTK header files and just make them into fourth source? And I wrote a little conversion script to do that. And it took sort of like a Sunday afternoon. And when I was done, I had all of these files that I'm importing. What's happening here? Yeah, it says not responding. Oh, thank you for that. Well, the editor's hung up. Fine. You can see at the top, there's an X library declaration, and you can see the one for Windows and the one for Linux and the one for Mac OS. And then there are all the includes of the various files that I was going to show you, but my editor's hung. How do I make that stop doing that? Sorry for the technical difficulties. We will blame Parallels for this. Okay, well, if I could scroll down to the bottom, you would see that there are over 500 source files, fourth source files, to get all the GTK functions. And I took all their enums and made them into fourth constants, but it's all there. And I really want to show you the rest of these. How do I get to there? Can I close that? Can I go here? No, the entire VM is locked up. Okay, well, I'll just have to use a text description of the rest of it. So I took the object hierarchy, which is here. At the top is the G object. That's sort of the fundamental starting node for everything in GTK. For all of the graphical things, I can't get to that. How do I make that go away? Drag it. There we go. The widget, you can see the widget is a child of the G object. This intermediate node, G initially unknown, doesn't contribute any data or methods, so we just skip around it. And we have the widget, and then we have various kinds of widgets. So the box is a subclass of widget. And if my VM weren't hung up, I would show you that. And then you have other widgets like a button and so on. And so what I did was I just made fourth-like names for the methods that would then invoke all of these ridiculously long function names in GTK to do things like new, give me a new instance. Within the G object at the root, all of it keeps track of the handle for each and every one of these widgets so that they just stay with its name. It just makes all the bookkeeping so much simpler, and it makes the code very readable. And I'm sorry I can't show you any more of the code since that thing is locked up and I don't know how to restart it from here without rebooting. So that truncates that. Any questions?
So curious, did you want to make sure did you have a corresponding fourth object for each GTK, the corresponding fourth class for each GTK object type?
Yep.
And,
yeah.
And then they call in the each of the.
Yeah, and it's primarily the widget types, but there are a few other things at a lower level. glib provides some things like timers, which are nice to have. At the top level, there's a actual GTK application, which is how you pass control off to GTK. GTK is single threaded. You don't have to worry about things being thread safe. It has its own executive. So once you pass control off to it, you can stay running a debug process in your own thread and do other things that are multi-threaded that don't use GTK, but the entire graphical user interface application runs in the single thread that's owned by that GTK application. But yes, so there's one class per GTK class. Anything else? If not, it's lunchtime. All right, thanks. And apologies for this thing locking up. It is, of course, the only time it's ever done that. Thanks.
Take a couple of questions, they can text them and I'll read them out to you, or.
Sure. Yeah, sir, we're not hearing anybody.
Everybody.
Yeah, it's still on, right?
Stand next to Brad, answer questions on his mic.
Is your mic on?
I think it's still on, yeah.
Okay, mute yourself,
Mute myself.
stand next to Brad,
Oh, sure, hold on.
and maybe do a little Q&A. Otherwise, we'd be going to lunch on time, and I can't have that.
All right, we can hear folks in the Zoom again. Sorry, we were asking you to reply, and it didn't occur to me that you couldn't actually speak.
And there are no questions. Is the mic on?
I think the mic's on. We're hearing you on the chat, on the Zoom.
We're not
Does
hearing
anybody have any questions
but
for
we're hearing
Leon?
nothing from the speaker.
Leon?
Yeah.
You said this is SWIFT, object-oriented programming?
Yes, SWOOP.
That's what
Okay. Yeah, it's part of SwiftWorld. It comes with it.
I would like to say that Leon has donated a year of MeetUp, and he is to be lauded or condemned for his lack of judgment. I'm not sure which. But anyway, thank you so much, Leon.
The MeetUp platform is nice and you use it really well.
We do. Okay. We're going to be going over to putting our agenda back on, I guess it was GitHub at one time. And the reason is that when you put in text on MeetUp, they have a tendency to, when you upload a file or paste a file into their edit box, they take out all the line feeds and just goof things up. They make things into quotes and so forth. So what we're going to do now is take lunch. We're going to leave the meeting room open, obviously, because it's always open.
I'd like to pause the recording, though, just in the.
We're going to pause the recording because you guys are going to be talking among yourselves. I recommend you go around the room and introduce yourselves. We'll miss that, and I'm saddened by that, but not saddened enough to stay here. I'm going to go eat. We'll see you guys. Hopefully it'll be about on schedule, but there's no guarantees of that because it's 4th day.
All right.